Hello,
Hello, Weston. Good to see you. Looking forward to the weekend.
and my summer come.
Yes, yes. It's oh yes. Are you still at school? Are
Uh,
you still having
this is
or
the last school day in this school term.
oh right. Congratulations. Hey. Do you what do you do over summer then? Do you have to go to summer school or what's your
No, but I need to finish all my summer homework.
oh I see. So does that mean they give you a lot of study to do over summer, like a project? Is it like that?
Yes, there are summer projects and summer homework for different subjects.
Right, right. That must be quite difficult for you to, is it self-study? You have to study self-study and then do you get any help with that or do you get anybody from school to if you have any questions, how do you get help? Or do you have to just call when you come back to school in September?
Uh, yeah, but I think I can finish this by myself.
Oh, well done, well done. That's great. The internet's amazing, Weston. It's incredible. Okay, Weston, we're going to have a look at this. IBM has has revealed, opened the world's first 2 nanometer chip technology. Are you, do you know much about or anything about semiconductors? Semiconductor, yeah, semiconductors technology. Nanometer, any idea what a nanometer is? I was
I'm
just trying,
really small.
very small, yes. I was just trying to quantify a nanometer, trying to give you a picture of what it may look like. A nanometer is very, very small. Um, right, I had a good one, a good picture just a moment ago. But yeah, it's very, very small. It's incredibly small. I think that's right. I'll just think it's just further back. Here we are. Right. So the diameter of a human hair, okay, is 100 microns, micrometer. Well, we go to a nanometer. This is, well, you could say, I think this is, yes, okay. A nanometer is one, okay, kilometer, right? We can work that, work
Okay,
that back. But
really
it's
small.
very, yeah, to save you time. There is a comparison chart. Yeah, that to say maybe that's better. Okay, it goes in increments size. I think the measuring nanometers. Yeah, that's right. For a millimeter, it's a million. A million nanometers can go into 1 millimeter. That's hard to imagine. I don't know how if you can, but Weston, that is a millimeter on our ruler, as you know, the very small lines. A million. We can break that down by a million. I can't even think it. So the IBM have put out a new technology, 2 nanometer. So not a million, but 500,000 can actually go into can actually go into a millimeter. So that's
Okay.
just mind-blowing technology. Right, so just very briefly before looking at the video, we looked at, I used to work at TSMC from about 2000 to 2000, and 10. So yeah, I remember when I left, it was about 22 nanometers were being discussed. That was about that. But you'll notice, I don't know if you can see a trend here. It's probably hard to see, Weston, but if I was to give you a chart, now this is from a student that I helped with from, yeah, that's a ASML, okay, Advanced Semiconductor Manufacturing Lithology. Anyway, what it is that every 2 years, it's called Moore's Law, the number of transistors in an integrated circuit doubles. In other words, the integrated will half in size every 2 years. So every 2 years, it'll get half. So here we are, 2 nanometers, 2 nanometers now. So will be, well, actually now it's every 3 years.
So the company want to make smaller and smaller.
Smaller and smaller. So that will be that we'll be looking at in the future. Well, at the moment, we seem to be ahead of it, but yeah, 2021 already, so we seem to be getting ahead. It's a breakthrough. Here we're predicting it to be 2023, but actually it's happening now. So yeah, so we're going to be going into, I believe, the next level, which is below the nano. So it'll be 0.9 nanometers. I don't know whether it is, that's true. No, 0.09 nanometer, something like that in 2 or 3 years' time. So incredible technology getting smaller and smaller. Yeah, so what changes do you think will happen to our lives with smaller technology? We're getting to a point where, have you heard of quantum computing? Quantum computing, Weston, have you ever heard of this before? Quantum, you may have heard of quantum technology. Let's see, quantum,
No.
let me write that down. Quantum technology. This quantum technology, okay, is a new development in computing, and what it is computers today are using bits. That's the ones and zeros, isn't it? Ones and zeros, called logic technology, logic or digital technology. All right, but quantum is using artificial intelligence, guessing. So they're moving away from the one and zero technology. So Weston, that's the new evolution of quantum technology, is it's becoming more artificial guessing. They remember. I'll give you an example. If you do calculation, say, I don't know, 5 + 4 = 9, right? So the computer will do the calculation, ones and zeros, right? With quantum technology, it'll just remember. It'll have a library and it'll remember, oh, right, did we do that before? I seem to remember we did 5 + 4, and it remembers it, and then it doesn't have to process it because it remembers it's done it before. Boom, there's the answer. Okay, so it doesn't have to go through the same processing, but traditional computers will do the same thing over again. So 9 + 4, oh yeah, processing, answer. Do it again, 9 + 4, processing, answer. They'll do the same thing again. With quantum technology, it remembers, and then it doesn't have to process it. So it's smart thinking, smart technology. And this is very useful for network security. So network security. That's to say that to stop viruses coming in, to protect your server. So very, very important for network security. So this is kind of like remembering that sort of type of virus or some sort of attack. That it helps to remember and identify better technologies. Very useful. Right, okay, let's have a quick look at the video. Hopefully it'll run smoothly this time. Here we go.
Semiconductors, the foundation of data processing chips at the core of computing, are a critical component in everything from our appliances to cell phones, transportation systems, infrastructure, and even national defense systems. Transistors are a
It should be removed off, so I'll try again.
type
Here we go.
of semiconductor. The more transistors on a chip, the more calculations it can perform using the same amount of power. The transistors are manufactured on silicon wafers, which contain hundreds of individual chips, sort of like a high-tech cookie sheet. 4 years ago, IBM created a revolutionary architecture designed to produce a chip with transistor components as small as 5 nanometers. Building on that breakthrough technology, this year, IBM has produced the world's first 2-nanometer chip. Its tiniest components are smaller than a strand of DNA. Designed and produced by IBM Research at its Semiconductor Research Facility in Albany, New York, this wafer contains hundreds of chips the size of a fingernail, each with 50 billion 2-nanometer transistors. This technology is designed to help improve calculation speed or boost energy efficiency, depending on the job. Where speedy, complex calculations are the goal, IBM's 2-nanometer design is projected to achieve 45% higher performance than today's 7-nanometer chips. Or, if energy efficiency is the priority, they are projected to use 75% less energy than 7-nanometer chips. This breakthrough will help accelerate advancements in areas such as AI, 5G and 6G, edge computing, autonomous systems, and space exploration. The 2-nanometer chip continues IBM Research's legacy of contributions to semiconductor innovations. These include the first implementation of 5-nanometer and 7-nanometer process technologies, single-cell DRAM, the Dennard scaling laws, chemically amplified photoresists, and many others. Now that IBM Research has made it possible, it shouldn't be too long before 2-nanometer technology becomes the industry standard. This kind of innovation from IBM Research has kept IBM's technology on the cutting edge, from 2-nanometer chips to platforms like IBM Power Systems and IBM Z to quantum computing and beyond.
Oh, wow. Yeah, any thoughts there, Weston? Have you heard of, oh gosh, IBM Z? Well, yeah, that's,
Yeah,
can I ask
lab.
you, do you know what type of computer you're using? Do you know what type of processor your computer is?
Windows.
Oh, okay, all right. Yeah, there's different computer processors, Weston. So I'm using an Intel. There's an Intel i5. I'm using an Intel i5 processor now, but the idea is that the technology that we have today is the processing of speed of basically there's many threads, anyway, I know it's complicated, so, but basically there's multiple ways to function. So many applications, your computer can multitask. So it's about multitask. So multitask, so the computer can do more things at the same time. And a lot of it is quad processor.
Processor. So people are now making smaller, faster, and lighter thing, like the semiconductor.
Absolutely, yes. Well, this is the idea that, and so Intel, there's now getting better and better. Like Intel 5, let's see, Intel 9. I think they do this. That's the 10th generation, which means multiple processing. You could do, you can applications. You can have Microsoft, PowerPoint, Word, Excel, Internet. You can open many pages. You can have Skype. You can have Zoom. Many things open at the same time. I don't know if there's an i11. Let's see if we got an i11. Yes, okay, right. So generations, so they're getting smaller, more transistors are in there, more and more things.
I know the Intel that I've kind of seen it before, but the technology I don't know.
Yeah, Intel, you'll see the core. This is the way there are many different, just very briefly, I'll just give you an insight how it works, Weston. Maybe this is quite interesting. This is an overview, company overview that I've helped. The idea is, it's called silicon. They slice it, they polish it, they have like a wafer. So it's like a very thin, and then basically they'll put a little mask, like a sheet of, and on that sheet is the design of the transistor circuit board. So there's a circuit on there, and then it's etched, somehow it's light etched onto the metal, and then they expose it. I've forgotten how it was now, yeah, to protect it so that it's etched, means it's colored onto it. Then they erase it, then they burn off the cover. It's called ashing, and then they do that. Then that's a layer, and then they do another layer on top. So like these are little silicon layers they put on top, and so eventually they'll have many different silicon layers, all built, different circuit boards placed on top of each other, and sometimes 30, 50 times to build. So each time they do a processor, goes round and round and round until they've got one that's got all the chips they design for it, for the processor, and they chop it up and then put it into a chip. So that's how it looks like, the processing. And they're very difficult to make sure that it's accurate. They have to do a check to see it has worked properly. So just an overview, Weston, gives you an idea of what goes on inside a microprocessor chip. It really is quite amazing. But applications, any ideas what you think you could see for the future? Yeah, visions of flying cars. I think they've got that starting now. I don't know, it just seems amazing.
I only heard of flying backpack, and I think car is too heavy.
Yeah,
I think scientists should invent a much lighter material and much stronger engine.
Yeah, I wonder if it's going to be like intelligent. I don't know. Let me just write that down.
If we are not using the way in magic like Harry Potter.
Yeah, I, I maybe there might even be something like intelligent materials as well, which could be something a bit like Back to the Future. I don't know if you remember that movie.
Yeah, and something like
To the
and the
future.
device that have the gravity.
Yes, that's right. Yes, and I think yes, that's right. And he had these special shoes that recognize his feet and just automatically. And we are getting some technology like this now. So it's but as you say, the anti-gravity concepts. I don't know how. I guess that would be. Would that be the drones, isn't it? The drone technology, the drone drone. Yeah, drone transport. Yeah, I guess that's having the ability to travel. I do believe there is going to be, I think instead of human, it may be deliveries. You know, we've been locked down with COVID, Weston, and I think this will be definitely something that's coming up. I think is the technology to get a package or a pizza, who knows, but something like this, even medical help to somewhere on a mountain. But I think delivery packages, I think is going to be something as well. I suspect maybe the bulk transport to a local area, and then the drones will take them to the places, possibly. I don't know. Can you foresee this in the future?
Yes, I think the drone can have a stronger technology.
Yeah, you know, maybe it starts with delivery. Maybe then human travel afterwards. Maybe for that sort of idea. But yeah, maybe down to earth.
Something that can fly by standing on a thing.
Standing on a board of some sort. Yeah, that's right. I think they're trying. They did something like that. Yeah, I think it's very basic at the moment.
Magic broom.
Broom. Yeah, I wonder. Yeah, they're looking at it. I know that at the moment, I think it's drones. I think that's what it is. Lots of little motors at the moment for human transport, but very, very, as you say, that the power has to be better. And maybe the smaller and lighter, as you say, it would be good if it's lighter, smaller. The power will make that happen. Yeah. Also, these. I mean, this looks like it's might be coming out. This is a
Smart glasses.
smart glasses. Yeah, possibly. That's interesting, isn't it? That's
smart glasses.
Wow. Is that? I don't know if it's a real thing. Whether this is just, but it is kind of practical, isn't it? If you're wearing, I guess you've got to know where the buttons are, because you can't see it. You'll have to do it the side. But I guess you could. I guess you know the buttons, which one is what, and you just press it to then you get a WhatsApp message or some sort of update. It's kind of cool, is that? Yeah, we might be seeing these sort of things, and possibly ways in which we can improve our physical.
And I think the battery should be better, or because you are also have the function of the glasses, so you cannot take off your glasses to charge while you are doing other things.
Yeah, that's true. Yeah, I guess it's interesting that if it's the glasses, maybe they must have. They could have some. What's it called? Yeah, some sunlight. photosynthesis. Yeah, that's yeah, having the rechargeable ability, isn't it, from the sun. And my mind's just gone blank there. But, yeah, that having that ability to charge, isn't it, from the sunlight and come in to be able to do that. Just my mind has just somehow forgotten what it was. But yeah, something like that to auto charge from the sunlight. So maybe the new technology that we could expect. I think you're right. I think that could be very interesting what the future could.
Yeah, and there may some computer or the robots that have the similar intelligence than human and can think like human.
Yes, absolutely. Yeah, some fascinating. Yeah, my mind's gone with what it was. Anyway, but yes, using solar panels. So have some sort of solar panel. Now this is quite interesting. Solar panel technology. These are solar panels you can put on the house. So more ability to maybe, and I heard that what they're going to do, or what we expect, materials, that the solar panels will be mixed with concrete or mixed into, instead of just having it like that, actually put inside the building material. So the actual building on the outside, like a brick, or like will have a solar panel on it, somehow embedded inside it. So even on the roof tiles, the tiling. So I think this is going to be the thing of the past. I think it'll be a mix. So it look like a normal house, but the material itself is mixed with the actual, so special material that will look like the material itself. So, and that will charge the house. So I think there's definitely something there. We can see in the future, as you say, the technology. So I think this material here, Weston, will probably become mixed with the solar panel. The solar panel will be like the new type of building material, and that will then be able to charge batteries inside the home. And then you can, yeah, don't need to use the electric so much, because electricity is very expensive. So I hope, and I think that might be interesting, that the power of things may be reduced. You don't have to use electricity so much. Like computers use less power. So fascinating, Weston. It's interesting future, what we're expecting in the future, where things are going to get smaller. But it's a breakthrough now. This has been a problem to break through this barrier. I remember they talked about, they were talking about 10 nanometers in 2016, or 7 nanometers. It was a barrier there. But yeah, they seem to have found a new way to get it even smaller, which is amazing. Be interested to see in your generation, Weston, you're going to see a lot of changes with the new technology as they get smaller. So keep an eye out for that. Nano wires, look at that. So even wire technology. And I think that could also affect the network, the network cable, and how more information could transfer through. But even nano wires. Now that's a just final point on that. Nano wires, is that the actual size? It is. Wow, nano wires. Wow. Yeah, right. Okay, so the cable itself could be made of millions of, and the wire itself could be many, many millions of strands of information could be passing through. So nano wires, incredible. Right, Weston. Okay, thanks for that. It was quite interesting that, yeah, nano wires. So lots of information could go through on a normal wire itself. So Well, we shall leave it there for now, Weston. I believe Josh is up next on looking at Marvel, the Marvel characters, so of the Marvel movie, where I think they're using a lot of nanotechnology. So enjoy the class if you like to join them. Otherwise, have
Okay.
a great weekend, Weston. Okay, take care.
Okay. Bye.